Okay, so I'm going to talk a little bit about the limitations of the power series method. So we're going to see an example where the power series method fails, or it just gives us the wrong answer. So we have this differential equation, which is, again, this is something that we would know how to solve anyway. This is a first order linear. The solution we would get is y equals c over x. But we're going to show that the power series method actually fails. And then I'll talk about why that is. But first, let's just try it. I assume y has a power series representation. So y prime is this. Right? So the differential equation becomes this. Right? And I can pull this x inside to make this x to the n. And now I'm in a bit of a funny spot. I would like to combine these two series. And the powers of x are matching up, so I like that. However, the indices of summation are not. Like here, n is starting at 1 here, and it's starting at 0 here. Meaning that this has a term corresponding to n equals 0, whereas this one does not. So here's how I'm going to fix this. I'm just going to separately write the n equals 0 term of this one. So the n equals 0 term would be c naught x to the 0, so I'll just leave it at that. Then what I have is the rest of this series I can say is starting at n equals 1, and I combine it with this series that's also starting at n equals 1. So I'm going to have a single series starting at n equals 1, and then I'm combining these. They both have an x to the n. In fact, they both have a c sub n, and other than that, it's just n plus 1. Right? And again, this 0 we can think of as a power series whose coefficients are all 0. So when I'm equating coefficients, the constant term on this side has to equal the constant term on that side, which is 0. And the coefficient of x to the n in general on this side has to equal the coefficient of x to the n in general on that side. So n plus 1 c sub n is 0. So c sub n is 0. So actually, they're all 0. So this is what we got. And yeah, so why did we say the power series method fails? We kind of got an answer, and it's even, I mean, this is a solution to the differential equation. I mean, if I plug it in, like this is just the solution where y is always 0, meaning that y prime would also be 0, and if I plug it in, it does work. So that is a solution. The problem is it's not all solutions. It's not a general solution. It's just one solution. For example, in particular, I can look back at this, and this is the answer that we would get if we solved it the way we learned months ago. This is like if C was 0, but it didn't, like the power series method didn't tell us the general solution. It did not tell us any of these other solutions like 1 over x or 2 over x or any of those. So this can happen sometimes. Basically, I would say the reason why is when we do power series, we're doing them centered at 0. And if you remember from Calc 2, a power series can be centered at any number, and if it's centered at a, basically instead of x, you write x minus a to the n. We're doing it centered at 0, so that's why it's x minus 0 to the n. But these can be centered anywhere, and the problem is, if we're centering this at 0, the general solutions have a very serious issue when x equals 0. These general solutions, like x equals 0 is a vertical asymptote for these. It's undefined at x equals 0. So looking for a power series that's centered at a value where the solutions to the differential equation are undefined is a bad idea. We could find solutions to this if we decided to have them centered at maybe another number. So this can happen. We'll talk a little bit about, more about like how do you know when this isn't going to happen, or how do you know when this might happen? Because this is disturbing, right? This kind of makes you feel like maybe we shouldn't trust this. But for now, just be aware that this is a thing that can happen. Another thing that can happen is that you'll get an answer and you'll find that the radius of convergence is 0, so it basically never converges. There's an example like that in the book, and I believe, is it example 3? Yeah, in example 3, they find one that has a radius of convergence of 0. So that can also happen. But anyway, let me leave this for now.